Assalamualaikum and good day. Welcome back to CMA422 Structural Design. For our next example is example number 3. This example is slightly different from the example number 1 and 2 for the reinforced concrete beam design. Let's read the question. A 100 mm wide singly reinforced concrete beam is required to transmit ultimate bending moment of 150, which this one we know it will refer to the breadth of the beam. If you draw, you will get something like this, right? That is the breadth 118, and the ultimate bending moment will this one refer to the M, inclusive of its own weight, meaning this question have calculated the loading for you and get the maximum bending moment. The beam is composed of grade 30 concrete, means that FCU 30 Newton over mm square with high yield reinforcement, which refer to FY 460, and it did not state any value or any type of steel for the shear reinforcement ataupun link tak ada diberitahu, but it's okay, we can assume whatever not given. According to the question, it asks you to determine the depth of the beam required, meaning the question asks you to find the H. The question also asks you to determine the amount of steel, meaning the S, and you have to design and sketch the cross section. So this one definitely says sketch the cross section. Actually, even all the question you have to sketch, and that is the final answer for every design problem. Right, so what we do first, we going to straight away pergi ke main steel. We don't need to calculate the loading since the soalan dia dah straight away bagi moment, ultimate bending moment. Therefore, tak perlu kira loading lah, sebab the loading is actually kita kira ultimate design moment adalah untuk dapatkan the ultimate bending moment. So first thing that kita tahu given is is 150 kilonewton meter. So bila dia bagi M 150, meaning it refers to the moment yang being transferred daripada loading di atas ya. Jadi bila kita nak design, kita nak design to the optimum. So we going to take this one as the value of the maximum. Kita nak sampai 150 kilonewton dia boleh support. Okay, because this is the actual loading yang being transferred, moment yang caused by the load. So kita akan anggap M adalah sama dengan MU, meaning whatever yang transfer boleh di-resist oleh the beam, kan? Because MU we know it is the ultimate moment resistance. So meaning that size of the beam, okay, kalau dia punya dimension like that, and that is the size, so it can resist as much as moment yang macam ini. So kita nak design to the maximum lah, design yang paling optimum. Therefore, kita pakai je formula MU equal to 0.156 FCU BD square and replace the value of MU with the M yang kita ada tu, because kita cakap M adalah sama dengan MU. Apa yang transfer sama dengan apa yang boleh di-resist. Okay, so 0.156, the FCU given grade 30 concrete, and B is 180, then we're going to find the effective depth, which is the D. Right, so here in my calculation, I get 421.975 and I round it up to 425. So D here is the minimum Kita jangan round down. Jangan nampak 421.975, so kita round down to 420. Kita kena round up. I round up to 425, or you can perhaps round up to 430. 450 doesn't matter, it's up to you, sebab this is your design. Tapi jangan melampau sangat lah. Kita tak nak design over design ya. Okay, next is we going to calculate K since kita dah round it up. Okay, kalau kita tak round up, kita still use this 421.975. Kita akan dapat K sama dengan 0.156. Okay, you get what I mean or not? So, kalau you pakai D, masih lagi 421.975. It is so obvious you akan dapat K adalah sama dengan K prime. Okay, tapi kalau you round up dia, okay, 425 for example, I round up dia, you will get a different value of K. Sebab kita tahu 0.156 tu adalah maximum for singly reinforced concrete beam. So, K takkan sama dengan K prime lagi sebab value dia dah berubah. Bukan lagi 421.975. If you use 430, you will get a different value also. And if you go lower, okay, contohnya you round it down, you pakai 420, right? So, K you akan lebih besar dari K prime. In this case, dia akan go lower. Okay, tapi kalau you round it down to 420, for example, you will get the value of K is bigger than K prime. Therefore, it is very important to tahu where to round up and where to round down. So, in our case here, since I round it up to 425, then when I calculate the K, I get 0.1538, or you can round up to 3 decimal places, 0.154, less than 0.156, which means it is still a singly reinforced concrete beam, less than the K prime. And calculate the Z, same, masukkan saja dalam the formula and I get 0.780D. Okay, which is less than 0.95. So when I calculate the steel area, I use this value. Okay, exact 0.78D kan. So 0.78D, D I replace terus dengan 425, which is the D yang I dah kira dekat atas. Then I get the 1035.443. From this, we're going to refer to the table. Right. So you have options. Since in the question, it did not mention anything about the diameter of main reinforcement ataupun diameter of anything. Dia tak ada mention any assumption there. So you can assume on your own. Okay, but you have to make sure the spacing is enough. Okay, itu yang our job lah. For this AS, what I can see is I can select this one 4T20, or I can select 3T25, or I can select 2T32. Tapi mungkin 2T32 bagi you terlampau berbeza. The AS beza around 600 mm square. Okay, compared to yang lain, kalau you ambil 4T20, it is around 200 mm square, and kalau you ambil 3T25, it is about 400 mm square difference. Okay, so tak apa. Maybe if I say that, okay, I think I would like to try this one. Okay, first. Right, so I cuba. Tak apa, kita cuba. So ignore my answer over there. Kita try to use the 3T25, okay, which is the AS is 1470 mm square. Right, then we can check the spacing first. Spacing is enough. So for the spacing, we have the B for beam is 180. So notice that 180 ni beam ini kurus. Beam ini tidak makan. So 180, we have to minus the number of main reinforcement. Minus dengan the diameter of the link, which is kita ada kanan dan kiri, that's why darab 2. So 2 darab 10 mm. So here is my assumption only. Okay, you can assume 8, you can assume 6 lah, tapi this is a normal assumption lah, 10 mm sebab kita tak ada design the shear reinforcement. Normally bila kita design, selalunya saya selalu dapat 10 mm, 8 mm pun ada, tapi because sometimes dia pakai combination of bars That's why you can get 10mm and 8mm. Tapi you akan ambil the biggest size lah, which is normally akan jadi 10mm juga. So that's why my assumption goes to 10mm. So 180 minus 3 times 25 minus 2 times 10, and what else? We have a concrete cover. Left and right, therefore dia jadi 2 lah. And it is 25mm. And you have to bahagi with 3 numbers of bar minus 1. Okay, therefore dia jadi 2. From the calculator, okay, what I get is 7.5 mm. Okay, which is this is less than the HAGG plus 5 mm. HAGG ni maximum size of aggregate 20 mm kan, so plus 5 mm, then it is 25. 17.5 is less than 25. So what does it mean? It's not okay. Therefore kita kena suggest another bars for this beam. Okay, that's why here my suggestion goes to 2T32. Walaupun dia punya beza dia besar, around 600, but we have no other choice. Kita dah tak boleh go for any other size here. Or kalau you pakai 40mm, tapi normally for beam kita tak akan pakai sampai 40mm diameter. Okay, because I believe that most tahu berapa besar 40mm tu. So it's a big bar and dia mahal lah, it's expensive. So jarang lah kita pakai for beam, beam saja sampai 40mm. So kita 32 here, okay, use 2T32, 1610 mm square. That is the AS for 2T32. Right, so when we calculate for the spacing, we find it is 46. So okay, okay, because ini ada difference from the one yang you compare previously. Okay, normally kita akan compare dengan HAGG plus 5mm. That's what usually I compare kan. So sekarang you ada dua benda you boleh compare. Ini sama dengan 25mm. Okay, kalau you pakai bar size 32, you tahu bar size ni lebih besar daripada HAGG plus 5mm. So you akan compare dengan the bar size, which is 32mm. Kalau you pakai 40mm bar size, you akan compare dengan 40mm. So normally lah kita akan just compare dengan this HAGG plus 5mm ni untuk bar size yang sampai 25mm lah. Okay, sebab after 25 it is 32. So 32 kita akan start refer dengan the bar size itself. So the value must be bigger than the bar size. Therefore, you dapatlah this 32mm. And another thing I nak mention jugalah sebelum kita terconfuse, another reason kita tak pakai this 40mm, satu sebab besar, dan satu lagi dari satu biji je. Okay, we cannot design beam macam ini, tak ada. Okay, so at least dia ada dua, kanan dan kiri, so that dia boleh ada shear reinforcement. Kita takkan design satu saja bar di bawah itu. After that, sebelum kita boleh draw or sketch, we need to get the value of h, since kita tak ada h lagi, the total height. So D, which is our effective depth 4 to 5, plus the bar size divide with 2, so 32 divide with 2 lah here, and plus lagi dengan the diameter of shear reinforcement or link, and plus dengan concrete cover. Then I get 476 mm, and I round it up to 480 sebab kita tak nak nombor-nombor yang tak tepat lah kat belakang dia, sebab kalau kita tengok dalam drawing, there's no such thing. So here, this is my design, which is we have two numbers of bar, 2T32, so I draw 2. Kalau you tulis 2T32, you draw sampai 4 bar. Salah terus, so tak ada marker sketch sebab you tak faham konsep. Okay, and the breadth is 180. The effective depth is 425. If you use 430, then put 430 And we know that tadi kita dapat dah kira the total height, which is 480 ni dia. So 480 you minus je dengan 425, you akan dapat this 55. Tapi kita tak perlulah nak tulis total height di sini. It's okay, just that one untuk you faham lah how actually I get this 55. And we have the assume link ataupun shear reinforcement, which is mild steel. That's what normally we use, and it is 10 mm diameter. 2T12 angle bar here, 2 biji. Right, so we cover all. So kalau you jawab ni semua betul, you will definitely get 3 to 4 marks for this question. Alright, so that will be all for example number 3. Thank you so much and have a nice day, and do not hesitate to contact me if you have any query or question to ask about the example. Okay, bye.